Hi, welcome to homework number 12. We're going to start with problem 1. Use the Laplace transform to solve the given system of differential equations. So the first thing I like to do, let's make this very big and readable, is I like to rewrite this in a more compact way. That is, x dot is equal to negative x plus y. And y dot is equal to 2 times x. Okay, and this was meant for both, so we'll just say like this. Now that we have this, let's apply the Laplace to this, because there's no way to decouple them just from this. And because these two would always add up. So, if I apply the Laplace here, what I'm going to get is, well, what is the Laplace of x, which is a function of t, and of the derivative of that? Well, that is going to be s, because we're getting into the s domain, times big X of s, because we're in the s domain, minus small x of 0. That's where you put your initial condition. And here we got minus big X of s, all added to the Laplace of y. That's going to be big Y of s. And we're able to do that because we're applying the Laplace to each term using its property of linearity, which tells us that we can apply the Laplace to each term of a sum, an algebraic sum, and that we can factor out constants, which we will do in this next one. So here we're going to have sy of s minus y of 0, small y of 0. And here the 2 factors out, and then we just get x of s for that right-hand side. So now let's input our initial conditions. So we have a couple of initial conditions. I like this color. X of 0 is equal to 0. So x of 0, we have it over here. They're telling us that this is equal to 0. And I'll just put it over here. And then y of 0 is equal to 1. So I can say that this is 1. Very good. Now what? Well, let's put them in standard form. So on the top, what are we going to have? Well, on the top, we're going to have s times x, and I'm going to drop the s's between the parentheses for readability purposes, plus big X minus big Y. All of this should be equal to 0. Here at the bottom, we're going to have what? So I got to move this over here. So here I'm going to have an x right here. Now, the bottom I'm going to move this x to the other side. So that's going to be negative 2 times big X. And then we're going to have this sy, and then that negative 1, I'm going to add 1 to both sides, and it's going to go over here. Well, now what can we say? Well, now I can factor out this guy. I can factor out this in this case. And what am I going to get? I'm going to get s plus 1, close this, times the big X minus big Y equals 0. And here I'm going to get negative 2 times big X. Maybe that negative, I can bring it in here. And here I'm going to have plus s times big Y equals 1. Now, before we keep going, let's just make sure that we didn't make any careless mistake somewhere. So, well, first of all, I want to point out where that 1 comes from. Then here, now I'm going to use this color. So first we rewrote it in a more readable way. We apply the Laplace. We recognize what the Laplace of x prime is Sx of s, big X of s, minus small x of 0, for which they give us the initial condition, which we use, and we say it's 0, and then equals to minus x of s plus y of s. And that's good. Then we bring the x to the other side, so we change the sign of that. We change the sign of that y too, and then the whole thing is equal to 0. On the bottom one, we have s times y of s minus small y of 0, which we substitute with 1. It has that negative in front, so it becomes negative 1, which we bring to the other side, it becomes 1. The 2x of s becomes negative 2x, and then sy stays the same. And now, from this, I want to show you two things. So we have that one, and I'm going to make a little space over here, and I'm also going to rewrite it the same way. So I'm going to have s plus 1 times this big X minus y equals 0, and minus 2 times x plus s big Y, all of this equals 1. Now, I am gonna try to eliminate either the x and the y's. So to eliminate the x, I need to multiply this top part by 2, but I can't just do it to one side of the equation. I gotta do it to both sides, otherwise I'm changing the equality. And then here, let me write this like this. Here I need to multiply it by s plus 1. And it's not just the first term, but the whole first left-hand side and the right-hand side. Just like that. Well, now that I have this, I can add them together, because as you see, when I multiply this, I get 2s plus 1 x and minus 2s plus 1x. So when I add them together, that term is going to cancel out. So I can just say that this term right here will cancel out. And at the bottom, we're going to get, well, 2 times negative y. That's going to be negative 2y, negative 2. And I'm going to hold on writing the y because I'll factor it out. And then here we're going to have s plus 1, s plus 1. And we have that s, so plus s, so I can write it over here, right? And all of that is going to be equal to s plus 1, because 2 times 0 is just going to be 0. So all of this is going to be multiplied by y. So now we end up with y is equal to s plus 1 divided by s minus 2 times s plus 1, right? Are we doing good so far? Because at the bottom we had that s. Actually, I made a little bit of a mistake already. So this is because you skip steps. So if you have s plus 1 and you multiply it here, you're going to have s times s plus 1. And then you have that minus 2 there. So you're going to have s times s plus 1. Let me rewrite this, s times s plus 1 here. And then you're going to have that minus 2. So s times s plus 1 minus 2. Okay. Now we're going to do the same thing over here. I want to add them together so that I cancel the y. So I just need to multiply this top one by s and then add them together. And if I do that, what are we going to get? Well, here we're going to get s times s plus 1 minus 2, all of that multiplied by the big X. Here, this is going to cancel out right here. And no, I want this black color. And all of that is going to be equal to 1. So now we get that this big X is really equal to 1 divided by S times S plus 1 minus 2. And now we have our two things. Notice how the denominator is the same. It usually is when we use this technique where we multiplied by the other's coefficient and we add them. And now that we have this, we can put it into MATLAB and get partial fractions for both of this. So if I do that real quick, I'm gonna have part frac, and I'll show you how to do this in the next video. S plus 1 divided by S times S plus 1 minus 2, and all of that is the denominator of the fraction. And I can copy and put a 1 in the other one. Put a 1, press Control Enter, and what I get is I use part frac, so I'm going to tell them part frac in MATLAB, and what we get out of the first one is going to be 2/3, 1 over S minus 1, so 2/3, this is still the big Y. This is an equivalent form. 2/3 times 1 over S minus 1 plus 1/3 plus 1/3 times, I don't know if you can read that 3, 1/3, just like that, times 1 over S plus 2. So this is going to be 1 over S plus 2. Well, now that we have this, what do? Well, let's do the same for this Y, this X. So we still get the big X, and that's all going to be equal to part frac in MATLAB, which is going to give us 1/3 S minus 1. So this is going to be 1/3 times 1 over S minus 1 and minus 1/3 minus 1/3 times 1 over S plus 2. We do that right here. And now we apply the inverse Laplace. And this is the fun part. So we apply the inverse Laplace here. And we say that this is going to be the Laplace inverse. And so here we get y of t, because now we're back in the t domain. The 2/3 stays outside because it's a constant, and we're leveraging the linearity properties. Now if I look at the Laplace table, do I have 1 over S minus a k? A 1 over S minus a k. Yeah, I have 1 over S minus a. So where that a becomes the coefficient of the t of the exponent of e to the at. So this is going to be 2/3 times e to the a, which in this case is -1, t. And here we have plus 1/3. And that could fit the same pattern. I just see a plus 2 instead of a -a. So, and that brings up a good point that here the a was positive. And so it was 1. Here, since it's positive, it must be S minus -2. And so if I recognize the pattern, I got to get this whole thing and put it into the exponent of the e. So that's going to be e. Oh, I don't like that. E times to the negative 2 times t. And this is going to be my y. And now I want to do my x. So I apply the Laplace inverse here as well. And I get x as a function of time is going to be equal to 1/3 e to the t, because again, this is s 1 over s minus a, and that fits the pattern that I'm trying to match from the Laplace table. And then here I'm going to have negative 1/3 times e to the negative 2t here, because I have s plus 2. So I reasoned that it must have been negative 2. And these are my results. So now I would write over here that my y of t is equal to 2/3 e to the t plus 1/3 e to the negative 2 times t, and that my x of t is equal to 1/3 e to the t minus 1/3 e to the negative 2 times t. And now I'm going to show you in the second portion of this problem how to check your result in MATLAB to make sure we did it correctly. So I'll see you there.